I have created a demo for YouTube RAG agent. You can provide any video to it and get the answer on the basis of its content. Let's see the demo. I have provided the YouTube link here and the agent provide the answer on the basis of the content of the video. This is possible due to RAG. RAG is Retrieval Augmented Generation. In this video, we are going to see the working of the RAG, what is RAG, what is vector database, and we'll walk through this code of this particular demo example. LLM can only provide answer to the knowledge which it has. For providing the knowledge to LLM, there are only four options. First of all, we can provide the prompt. Second is RAG. Third is fine tuning, and the last one is the pre-training. So what is RAG? RAG is the combination of LLM with the external knowledge base. These knowledge base are the vector stores where we store the vectors. Vectors are the numerical representation of the information, be it video, audio, or text. For the simplicity of the understanding, we can consider vector as the language understood by the model. Let's go back to the demo. What exactly happened in the demo? When I have provided the YouTube link, it was converted into captions. That was later converted into vector, and with the help of embedder, it is stored in the database. So in this case, we were using pgvector as the vector database. For fetching flow, when I wrote the question, it converted the question into the vector itself with the same embedder, and it tried to find the similar content in the vector database. And once that information retrieved, it is provided to LLM model, which take that information, give you the answer which is needed. Let's look into the code. So in this code, there are two files which we have. One is for the front end and the second one is the back end. The front end is made with the Streamlit, which is really nice for creating demos. You can create the UI in the Python with the help of Streamlit. Other file is the backend file where I have created two APIs. One is for writing the captions, like this is for the ingestion flow. The other one is for the read, like the ask API. So when we ask the question, it will actually get the data for us. For this particular demo, I have taken the video of the recent interview by Satya Nadella. I'll take the link of this particular video and put it into our UI. And once I click it, it will upload the video here. I can play the video here itself.
Satya Nadella, thank you so much for doing this.
Meanwhile, this is being played. We can see the captions being processed successfully. Let's see in the app how exactly this has been done. It should be coming to this point where we are actually entering the URL and URL is getting captured here. We are doing the embedding of that particular video. This is the API call which we are doing for the right caption here, and this call will land it to the backend. So this is our backend where we get the caption. So if we look into the logs, we are printing the video ID and then we are actually printed all the captions which we have. It is actually added 3 documents in the document base. We have defined the agent. We have defined which model we wanted to use. We have used the Gemini 2.0 Flash experiment, and I have used this because few free calls in the free tier. I have added the knowledge base and then I have added one instruction. This is like a prompt which I have given. If you wanted to see how exactly our knowledge base look like, knowledge base is something like this, where we are asking the knowledge base to read from the path which we have given here, and we are storing everything in pgvector. In the git repo, I'll put how exactly we can run the pgvector in local with the help of the docker, and you can follow the same. With this flow, we got our embedding in the database. If we wanted to see, we can check that out. So for that particular video, you can see that the embeddings are stored here. All the vectors embedding are stored here. These are the numerical representation of all the text so that it can be searchable. Coming back to the example, once the captions are processed and stored as the embedding, so we can ask the question here. So as we can see, the few main topics which has been discussed in this particular video, one of them is the future technologies trend that has been discussed. Let's say we ask the same question, and this will go to the PG vector database and find the similar thing and give it to LLM. Let's see the response. So it has successfully able to tell us the future trends that has been discussed in this particular video. Let's see the code, how exactly this has been executed in the code. We write the question, it will actually come to this front end. Front end will pass this to the API and ask API. So in the backend, it will come to the ask API, which we have written here. And this particular ask API will come to the agent which we have created. The same agent with the Gemini 0.2 Flash experiment, and we have given the knowledge base from which we have to retrieve the answer, and we have given the instruction to it. The knowledge base is same with the pgvector database, same chunking strategies which we have given. When we do agent.run, we'll get the response, and that response is sent to that particular response is sent to the UI. So user asks what are the future technology trends discussed in this video, and a function has called to search the knowledge base, and the knowledge base has been searched. All the relevant information has been extracted from that. This has been passed to LLM model, and on the basis of this, LLM model has given us this particular response, which we can see on the UI. So you have just now seen a naive example of RAG. There are many real world examples that is already in the production. If you notice any of the example, do let me know in the comment down. In this video, we have created RAG with the help of PhiData. I have checked out the Crew AI website also. They have the similar tool. You can try the YouTube RAG on the Crew AI too. I'll put the link of that particular example in the description. So if this video has added any value to you, consider subscribing this channel and hit the like button. Until next time, keep learning. See you in the next video. Bye.